Okay, so start the same way. Put the derivative both sides. Question? Raise your hand, please. What's the first rule? So hands up, what's the first rule we use? Let's go Dawson.
The square root rule.
Square root. How many knew it? Point, 2 for Dawson. So next line is going to say y prime is an acceptable abbreviation. So 1 all over 2 square root 4x cubed. Subtract 3. Because the square root rule says, here's how I memorize it. The derivative of the square root of something is 1 over 2 times square root of that something, and last part's always the same, multiplied by derivative of the something. So I'm starting with the square root of something, something being 4x cubed minus 3. Last part of the rule is always d over dx of that same something. Most of the rules follow that pattern, so that one's easy to memorize. We want to talk more about that. Cool. So next line, y prime. Again, no ditto marks. So 1 over 2. Hands up, what rule gets used? So this was the square root rule. From here to here, what rule are we going to use? That's a bad arrow, let's fix that. So this way. So what rule are we going to use? Say it, Abby. How many knew it? Point, 2 for Abby. So I need a big parenthesis right there, because this is like one big factor times another big factor, but this factor will become 2 separate terms, 2 things adding. So they have to be in parentheses so that it's still one big factor times the other. Question? Next line. Y prime equals 1 all over 2 square root 4x cubed, subtract 3. As I look at this, I'm thinking of something nice, simple, fast, easy. Raise your hand if you can read my mind. So I look at this, I notice something like, oh yeah, this is good news. So what am I thinking? For Kylie?
d3 over dx equals 0.
How many knew it? Point, 2 for Kylie. That's 0, I'm done with that. So this is gone. I need a rule here. Hands up, what rule am I going to use here? Let's go Aisley.
Multiplying constant rule.
Perfect. So I'm going to pull out the 4. So I've got this. When I pull out the 4, this will be multiplied by the 4, so I need some parentheses. I'll be left with d of x cubed over dx. Minus 0 doesn't matter anymore. How many anticipated this correctly? Point, 2 for Aisley. Question? Please.
Why is d3 over dx 0?
0. Oh, you were at the CCR.
Oh.
Yeah, don't worry. Oh, it only takes a minute. So I was just like, I forgot why you didn't notice that. Here's why. The short answer is derivative means rate of change. So when we write d of x squared, an x squared function looks like this. Okay? So at each and every point on this function, the rate of change is different. That's why we're trying to find a formula to calculate that rate of change. Good with that?
Yeah.
Okay. D of 5 over dx, or D of 3 over dx, that would be like a function whose value, instead of being x squared, the value is always 3. So a function like that would have this appearance, and the rate of change is always 0. The tangent slope is always 0, so this derivative is 0.
Oh, okay.
Does that feel all right?
Yeah, that makes sense.
Good job, Rachel. 2 points. Anybody else? Okay, please note, this is just one big, well, let's finish here, I guess. So now we use the power rule. So y prime equals, you can start combining if you want. This is just one big fraction. The 4 is on the top. People ask me that quite a bit. They'll say, how do I know the 4 is on the top, not the bottom? Do you know the answer why? Hands up, come on. That gets asked quite a bit in class. Like, how do I know that this 4 is on top, not bottom? Because you can write it like this. Like, I can get kind of sloppy and, like, you wouldn't want to go here. That'd be bad. But I could do that. That's legal. But this 4 is still on the top of the big fraction. Ashley, how do I know?
Because it's just 4 over 1.
Perfect. It's really 4 over 1. If it were on the bottom, you would have to write 1 over 4 to make sure you are not losing track that is on the bottom. How many new? Point, 2 fractions. So it's on the top, which means the fraction multiplies straight across. So 1 times 4 is 4. We have this on the bottom. And now I use the power rule. So I bring down the 3. Remember, this is multiplied by this is multiplied by this. So these two are still multiplying. So you can put a dot if you need to. Well, that sometimes looks like a decimal, so I'm a little nervous about that. Just put a parenthesis here. So we have a 3, and we have dx. The new exponent will be 2. Last thing will be dx over dx. We want to talk more about that. Cool. Dx over dx is 1. So I have a big fraction. This fraction has factors of the numerator, and the fraction also has factors of the denominator. Raise your hand, I'll pay you. Oh, question.
Just a question with the 3x squared. For the power rule, it's like, so what is gx?
Gotcha. So this time when I use, you'll see it, I'll just get you to say it. So I'm looking at this, and I'm seeing that it matches this.
Yeah.
So what's in?
3
Perfect. What is being raised to the 3?
x.
So that's the g.
Oh, okay.
That is your question?
Yeah.
It's good work. 2 points. Anybody else? Okay, cool. What are the factors of this big numerator? Hands up. What are the factors of the big numerator? So, Sydney?
4 and then the, well, like the whole thing. I don't really like 4 over 2 is square root of 4.
Oh, my bad. I didn't ask the question very well. So the way it helps me to look at it is I see this as a large fraction. I see the top as being this and this and this. So I see these 3 factors in the top. And then what factors do you see in the bottom?
Oh, the 2 and then 4x, or 4 and then x cubed.
Oh, 2 more points. In the bottom, come on. The 4 is not a factor of the bottom because I can't visualize the bottom as being 2 multiplied by the 4. The 2 is really being multiplied by the square root of a bunch of stuff. So really, the bottom is best seen as just two factors. I wouldn't want to think of the four, those are just stuff inside. You good? Okay. So a rule you need to memorize. Flashcard if you need it. When you have a large fraction, you cannot divide unless top is factored, bottom is factored, and you are dividing factors. So that, 2 more points for Sydney, that illustrates why you can't do this. This 4 will not divide with this 4 to make 1.
So what should you do? Just like.
So the rule is, top must be factored, the bottom must be factored, and you may only divide factors. I've had a lot of people say something that I don't like to hear. They'll say this. They'll say, oh, look at this function, f of x, and this function might look like so. Like that. And I'll say, can you divide? And their answer will be, no, you can't divide because they're plussing. Okay? This class is about being very precise. Plussing is not a reason, okay? Can't, no. Points for everybody. Is this numerator factored? Hands up. If the numerator is factored, you should be able to tell me that what you see the numerator made of is stuff times stuff times stuff, or maybe stuff times stuff. So is the numerator factored? Let's go, Clarissa.
Yes.
How many agree? 2 points, 3 for Clarissa. Somebody else. What are the factors of the numerator? Hands. What are the factors of the numerator? Rachel?
X plus 7 and then x minus 3.
So, factor of the numerator, factor of the numerator. Who knew it? Point 2 for Rachel. Hands up. Is the denominator factor? Hands. The denominator factor. Tori?
Yes.
Yes. How many agree? Point 2 for Tori. What are the factors of the denominator? It's a lot about perception here. Hallie?
It's the whole.
It's the whole thing. So the denominator is not very interesting as far as factors. It's like one big factor. But because I have a factor of the top, which matches factor of the bottom, division is legal. Those two divide to make 1, unless x has a value of -7. Question? No canceling. No saying that you can't divide because it's plussing. Okay? Top must be factored, bottom must be factored. You can only divide factors. You got it? Perfect. If you've been saying plussing your whole life, it's all right. I forgive you. Stop saying it. Okay. Are we good? So here, we've identified the factors of the top and the factors of the bottom. So this 4 can divide with 2, leaving a factor of 2. 2 times 3 is 6. The x squared cannot divide with the x cubed. So we're left with let's see, 2 does 6. Anyone want to talk about that? Please, Mary.
So you have to, so is the -3, does that have like a 1 by it? Or is that just, okay, never mind.
Oh, no, I got you. Hey, hold on. The ticket bequeathing ceremony. Make the long walk to the back. No, I really like your question because it's a habit I have that I think is very useful. I picked it up in engineering school, and I don't see a lot of other people using it, but I think you should. Like, I don't make you use this, but I think it really helps. In calculus and classes beyond, the problems get kind of complex. And so it's really easy to lose track of what is inside the root versus what is not. So some teacher had long ago would always put a little close on this to show that I'm closing it off. That's all. Is that what you meant?
Yeah.
Yeah, that's just me closing it off. Same thing you'll see, if I ever write a Z, I always do that. Yeah, I don't want to mix it up with the 2. Yeah, you don't want to mix up the Z with the 2. So I think it's interesting that in Europe they don't say Z, they say Z. Yeah, really, in Europe they don't say Z, they say Z.
Wait, like British people?
Yeah.
Accurately stated. Very cool. The thing that messed me up is I was reading in my job, I was reading some documents from Europe, and they switched the decimal and the comma.
Oh, yeah.
Yeah, like I was mixed up for a while, like, oh wait a minute, I figured it out. It's like, okay, that's confusing. Everybody good here? Oh, please.
So do you know you're like ready to, okay, so after you get to dx over dx, and then you simplify, that's when you know you're done?
The reason you know you're done, think of it this way, Ashley. 3 points, really good question. Take 4. 5. No, 5 is good. Look, right here, okay, that's what we're looking for. We're looking for the derivative of this function. And on a calculator, you can literally just type this in, okay? But without a calculator, we don't want to have any ddx. We want to use the rules in a sequential fashion until there's no ddx operator. Then you know you're done.
So that's the answer.
So this is the derivative, which is what we're seeking. So
Is d over x over d over x over d of x, is that the only way to get rid of d?
I have to write it down. Hold on a second, Carson. Let me stop the video.